Okay. So what are the different Java versions we have seen? And let's go to Java features. So Java features we have, so there are so many, and you can see here all of them. So Java is a simple programming language, object-oriented programming language, portable, platform independent, secured, robust, architecture neutral, so interpreted, high performance, multi-threaded, distributed, and dynamic programming language. These are all the features of Java. So why Java is a very simple programming language? It is easy to learn, and so syntax is very simple. And also, basically, this Java has taken from the syntax of C, C++. And that's why it's very easy. And also, Java has removed a complex topics like pointers concept, operator overloading, that was there in the C and C++. That is removed in Java. So without that, Java is designed. And there is no need to remove unreferenced objects by you. Automatically, a garbage collector will keep running in the system. That will clean up. So if unused, unreferenced object is there, that will clean up by the garbage collector. There is a daemon garbage collector in the system. It will keep running frequently. If it finds any unreferenced objects, that will clean up, and your system memory will be cleaned up automatically. So that performance will improve, right? If the memory is so optimizing every time. If you're using, it won't touch. If you're not using, it will clean up. So that's another advantage. That's why it's a simple programming language. So object-oriented programming language. So basically, in the software, everything will be treated as an object. So objects are organized, in the software. You will work with objects only. The objects are going to have properties and behaviors. So basically, a data is going to be object. So properties are defined with the data types, and behaviors are written with the methods. Behaviors are written with the methods. And how you will deal with these objects, that will that will be explained by this object-oriented concepts. So basically, object-oriented concept is nothing but it's a framework, basically. And that framework will tell how you can utilize and optimize your code by following some instructions and rules. If you follow the rules, you can manage your code easily. You can maintain your code easily. And it's going to be very easy if you follow the rules. OOPS concept rules, if you follow, your code is optimized. Your code is efficiently written. So that's this OOPS concepts. So there are basic OOPS concepts. What are the OOPS principles or OOPS concepts are? Object, class, inheritance, polymorphism, abstraction, encapsulation. These are the 6 OOPS principles or OOPS concepts, we call them. So I'm going to introduce object and class very early. So these things we'll discuss once the basics are over. Then third feature, platform independent. So what is platform independent? A platform independent means, let me give you a diagram how why Java is a platform independent. Platform independent is nothing but your code can be run on any platform. Then how is it possible? So what is happening behind that? So let me explain in detail, how Java code will execute so that you will get a better idea. Just seeing some. Yeah, so you can see here, so simple how your Java code will work, right? So this is the diagram I want to show you. First, you will write a Java code in the any notepad or any IDE tool, right? Once you write the code, that will be saved in this format, hello.java. So this is the input file for your Java, okay? So once you write the code, you will save the file with a .java extension. What is the file extension of Java? .java. So once you give this file and you first, this Java code is a plain English code you will write here. That will be compiled by the compiler. There is a Java compiler. Java compiler name is called Java C. So Java C will compile the code. So once it is compiled successfully, then it will generate the byte code like this 0011110. This is the byte code. So that means this plain English code is converting into a byte code by the Java compiler. The compiler name is Java C. Java C is the Java compiler. So then another file will generate automatically. Once compilation is done, you will get a dot class file with the same name. Hello dot class file will generate. The compilation is successful. You will get, but this is not readable. So this dot class file is not readable, but dot Java file you can read. So this is the dot Java file. So this is the Java file. You can see this is the plain English code, right? This is all plain English code. This is the dot Java. So the dot Java file is a normal code. Okay. So this code is converted into a bytecode by the which one? Java C compiler. So Java C is the tool, one tool. Once you install Java, you will get automatically. That Java C will convert this English code, English human readable code into a byte code that will generate a dot class file. So you have a dot Java file, you have a dot class file in the same folder. So once a dot class file is loaded, then there is a JVM, Java virtual machine, Java virtual machine. Once you install Java, Java virtual machine will be there. So every machine has a Java virtual machine. So the Windows, Mac, Linux, they have their own JVMs. So every JVM has so many components. We have different components. That component inside, there is a different components we have. I will explain that components later, maybe tomorrow's class. And so that that class will first, this dot class file will load into JVM by the class loader. Class loader is the one of the component of JVM that loads and it will store in the memory. So there is a memory areas. In the memories it will store. Then there is a execution engine in the JVM. So interpreter is the one of the component. The interpreter will take this bytecode stream and executes the bytecode stream and produces the output. So this is the how your code will execute, Java code will execute. First, what you will write a .java file with all the human readable code. Then first Java compiler will compile the code. So once the compilation is successful, dot class file will generate. So this dot class file will be loaded into JVM, and that means your machine Your so this JVM is there in your operating system, in your Windows or Mac or Linux. So that machine inside JVM machine inside the dot class file will load. That means bytecode you are loading. That bytecode is going to be executed by the interpreter. Execution engine inside there is an interpreter component that interprets this bytecode and executes a line by line instruction, bytecode instruction, and then result will be produced to you. Then the result will be in the human readable format you will get back. So this is the whole process how Java will be executes. So this is the one. Say write the code .java file. This is the Java source code. This is the Java source. And then compile. Compilation is done by which tool? Java C. Once compilation is done, then this dot class file will loaded into JVM. So then there is an interpreter. Interpreter will run the machine understandable code and output will be given to you. So this is the, so your operating system cannot understand the English code. So you have to convert this into machine understandable code. So then that machine understandable code will execute by the interpreter. So then output will be generated to you. So this is the process of how so JVM will work and how it is. So this is the one. See, class loader, I told, right? Class loader will load that dot class file, that dot class file, this one, into JVM. So this is the JVM components. These are all. So all these components and Java interpreter will take and see garbage collection, threading, everything will be available here. So these are all parts of a JVM. Okay, and that's how Java will be executed. So this, why I'm telling that is, why this is a platform independent is that a dot class file is common to all the platforms, so that you can write the code once, run anywhere. You can write the code once, run anywhere. So that's why Java is a platform independent. So you same dot class file you can run on Mac and run on Windows and my Linux, because so the bytecode is common to all the JVMs. So that even though JVM is different for Mac, same class file will run. Same class file, dot class file will run on Windows and Linux also, because the bytecode is common to all the JVMs. That's why Java is a platform independent and portable language and architecture neutral. It doesn't depend on the architecture of your operating system. If it is a 32-bit, it will run. If it is a 64-bit, it will run. Even a different processor you have, it will run. So that's why Java is a platform independent and also it's a portable language. It's a architecture neutral. It doesn't depend on the architecture, what processor, what hardware you're using. It doesn't depend on that. So that's why Java is a platform independent, portable language, and platform independent, architecture neutral. So why it is a architecture neutral, why it is a platform independent means you have to tell all this thing. Java source file will be compiled first by the compiler and generates the dot class file. The dot class file will be loaded into JVM. JVM will run that the bytecode stream and it produces the output. So that bytecode is common to all the JVMs. So all the JVM is every Mac JVM is different, Windows JVM is different, Linux JVM is, but the bytecode is common to all the JVMs. That is the reason Java is a platform independent. You can write the code once, run anywhere. Is it clear why Java is a platform independent? Any questions? Okay. I hope I'm guessing you don't have any doubts. So let's see. So Java is a secure programming language because it's a virus-free system. So you can use, because if you observe this, The pointers concept is not there in Java. And also Java code will run very deep inside the OS, but C++ code on the OS level only it will execute. But the Java code will execute OS inside, you have a JVM layer. JVM inside your Java code will execute. That's a deep security will be there. So I already told JVM inside you have a class loader, bytecode verifier, security manager, all these components will be there inside this JVM. So that's why very deep inside your code will execute. And so there are inbuilt security layers will be there. Otherwise, you can integrate other security providers also, like SSL means secure socket layer. So Java security layers also this one, cryptography. All these you can integrate with Java. You can work with Java. So that's why Java is a secure programming language. And Java is a robust programming language. Robust means a strong memory management is there. A dynamic memory management allocation will happen. So once you create objects, automatically memory allocation happens. Once you create object. So, and there is a lack of pointers concept, security problems won't arise. So automatic garbage collection is available in Java because, so once a garbage collection is there, it will keep finding out any unused objects or unreferenced objects are available that will be cleaned up. So that memory will be freed up. So that's another advantage with this. And another thing is, so Java, you have a exception handling concept. So it will handle the runtime exceptions. And also you have a type checking mechanism in Java. All these points makes Java very stronger. So basically robust means very strong. So Java is a very strong programming language. And it's a architecture neutral. I already told why it is architecture neutral because of bytecode. Portable language, you can carry forward the same bytecode to another platform also. That's why it's a portable. High performance language because it's a interpreted programming language. So it's a very close to your native code. That's why it is a faster little bit. Distributed, you can so Java is a distributed programming language. So even you can create this distributed applications with Spring Boot and Spring Beans. So that concept you can apply here to create the distributed applications. Multi-threaded, every web application, media player applications, all these are automatically implement multi-threading concept. Basically, multi-threading means each program will run concurrently, execute concurrently. For example, you are accessing one video. Same video I can access. How is it possible? Because of multi-threading. So same application you can access, I can access because of multi-threading. So what will happen is, so the resources occupies only memory once. Same memory will be reused for how many people are accessing that. Each resource accessing by the other person, one thread will create for the same resource. So like that, so multiple threads will create. And this, for example, this web application is accessible by all the people, 8 people. So 8 threads will create. But memory is same memory will be shared by all the 8 threads. That's the advantage here with multi-threading concept. So it's a dynamic programming language. It supports a dynamic loading of classes, whichever the classes you need on need base, on demand, the classes will load into JVM. So that's why all these are Java features. Java is a simple programming language, object-oriented programming language, platform independent, secured, robust, architecture neutral, portable language, high performance, multi-threaded language, dynamic programming language, and distributed programming language. That's all Java features. Okay, so I'll stop here. And so if you have any questions, I'll answer.